It begins as all epical questions do, in the narrow band where instruments hum and human intuition pricks, when a sliver of hyperbolic light trespasses the solar threshold and reminds us that our neighborhood has doors, and some of them open inward. You feel it in the way telescopes pivot just a little too quickly, in the way technicians lean closer to screens as though nearness could lend clarity, in the way the numbers refuse to sit still even as they settle into significance. There is nothing mystical about a trajectory. It is simply the handwriting of gravity written on the sky. Yet sometimes the pen jitters, the ink catches, and the line declares a signature we don't recognize. The interstellar designation, 3I Atlas, arrives like a headline negotiated between sobriety and wonder. A third messenger from beyond our star's ancestry. First, the cigar shadow of Oumuamua, then the crisp coma of Borisov, and now a needle of cold intent threading between planets. In its wake, familiar equations acquire a halo, and familiar agencies acquire questions. Somewhere in a control room, a clock clicks over the second that divides we think from we know, and a team decides whether to publish raw or polish. The sky, indifferent, continues to burn, and the visitor falls toward us with the composed inevitability of a prediction we were not ready to make. They called it 3I Atlas because the Atlas survey tagged the motion first, but the name does not carry the weight of what it is, an outsider bearing the momentum of another son's childhood. Interstellar status is not a title, it's a diagnosis. Heliocentric excess speed, eccentricity greater than 1, a path that refuses to be captured. Observatories from Mauna Kea to La Palma tuned out the ordinary chatter of near-Earth rocks and listened for the accent of elsewhere. What returned was a light curve with a staccato bite, a rotational sea, audence that didn't map cleanly to standard rubble piles, and a spectral palette that whispered metal in one band and carbon in another like a bilingual text with missing pages. The community shifted from curiosity to vigilance. When a thing is not ours and will not stay, we have one chance to learn. NASA's working groups spun up, coordination memos flew between survey teams, the Planetary Defense Coordination Office asked for best-case windows, and the Deep Space Network penciled contingency allocations that looked suspiciously like anticipation written as policy. The public narrative remained cautious, third interstellar candidate under review, while the private Slack channels pulsed with the electricity of a threshold crossed. Even caution has a frequency. Even caution has harmonics. The first days were a symphony of photometry and astrometry. Pixel crumbs collected across a carousel of telescopes, each measurement a stitch in a geometry we pretend is simple. Astrometric residuals, those tiny errors that tell you where your model is failing, sat mostly quiet, which was almost disappointing, because quiet can masquerade as completeness. The preliminary orbit solution gave an eccentricity larger than 1 by a margin that didn't need dramatizing, an inbound velocity that made the solar gravitational well look shallow, and a perihelion distance that promised a good look if we were quick. Spectroscopy yielded an albedo estimate shyer than rock and brighter than soot, while mid-infrared hints suggested a surface that shed heat reluctantly, as if armor lay just beneath frost. Radar windows were tight. The object was small or smooth or both, returning echoes like a whisper against a canyon wall. Light curve inversion models argued among themselves, proposing a flattened ellipsoid 1 hour and a cluster of contact binaries the next, each solution fitting the data the way a dream fits memory, true enough to live in, fragile enough to break. The software smiled, uncertainties narrowed, teams exhaled. Then came the night when the curve kinked, not much, just enough to place one itsy residual outside the comfort fence, to turn certainty into a question with better grammar. The anomaly arrived with the modesty of a decimal place and the audacity of a new chapter title. Between two tightly calibrated epochs, corrected for atmospheric seeing and instrument drift, A non-gravitational acceleration term crept into the best fit model, a sunward nudge that did not belong to radiation pressure alone and refused to be dismissed as coma dynamics, given the absence of a classical coma. Oumuamua had taught us caution here, had taught us that sublimation can wear unfamiliar masks. But 3E Atlas offered neither dust nor the telltale CN bands that let comets confess. The residuals weren't wild, they were elegant, consistent across independent pipelines, like footsteps in snow, too deliberate to be chance. JPL's fit added A1, A2, A3 coefficients, the bookkeeping for forces that do not curve from mass alone, and the discussion turned hushed. Radiation pressure would demand an area-to-mass ratio at odds with anything boulder-sized. Outgassing could mimic intent, yes, if the vents were placed just so and the spin state cooperated. But the thermal model needed fine-tuning that felt more like choreography than geology. Somewhere a meeting slid off the calendar and into a room with fewer people, and a label in a spreadsheet turned from artifact to provisionally significant. Human imagination does not need permission to accelerate, but science does. And so the hypotheses marched in rank and file, even as late-night conversations strayed toward edge cases. Natural models came first, an exotic comet with super-volatile reservoirs buried under a refractory crust, a fractal aggregate whose porosity raised its cross-section like a sail, a fragment from a tidal disruption event whose microstructure had turned it into a wafer. Each possibility was plausible enough to keep dignity, improbable enough to keep hunger alive. Then came the braver wedges of thought, Harvard papers recalled, breakthrough starshot concepts retrieved from old conference slides, the idea of light sails and non-Keplerian travel rehydrated for the moment. No one pinned craft to the corkboard, no one wrote probe in a primary channel. But they didn't have to. The shape of the conversation drew an outline you could recognize in the dark. If not mass-driven and not easily outgassing, then perhaps engineered, or at least engineered adjacent, a relic, a shard, a tool discarded by a civilization that was to us as we are to trilobites. The universe is under no obligation to be that interesting, Brian Cox might say, and yet, Michio Kaku would add, we are under every obligation to ask. Coincidences followed, stacked not like bricks, but like cards that may or may not make a house. A shallow radio quieting near perihelion, coincident with a magnetospheric pulse that space weather models said should have peaked an hour later, a high-altitude meteor train over the South Pacific with a spectral trace that made some inboxes ping, a neutrino event on the ragged edge of significance that theorists politely shuffled left on their slides. None of it proved anything. All of it flavored everything. We are pattern-making creatures, and the cosmos is a generous tapestry. Alignments are inevitable and often meaningless. Yet the timing wore a beauty that dared statistical scolding, a choreography that suggested the barest possibility of synchronization. An engine, if one existed, might flirt with the solar wind, might sip momentum from charged particles, might hum in a spectrum we do not typically watch. A rock, if rock is all it was, might simply be a patient liar, revealing only what our instruments ask in the dialect they speak. The wonder of science is that it grows stronger under the weight of both interpretations. The danger of wonder is that it does not know when to stop. Gravity is the cleanest instrument in the universe, and orbital dynamics its sheet music. 3I Atlas entered the system like a note held too long by another orchestra and promptly fell under the sun's instruction. Jupiter drummed behind the beat, Saturn added a bass line, and the inner planets contributed high, quick accents as the visitor threaded the tempo. Analysts decomposed the path into harmonics of influence, solar central, Jovian tides, faint whispers from the Kuiper swarm. They simulated slingshots we would never see, counterfactuals in which the object had approached a week later or a degree higher and would have been bent toward a different kind of goodbye. The non-gravitational term persisted, small but stubborn, a continuous breath against the score. Models that allowed a thin anisotropic thrust, micronewtons integrated over tens of days, reproduced the curvature without demanding an impossible mass. Models that invoked outgassing demanded a vent geometry that precessed just so, a thermal lag dancing with albedo patches in a clever duet. It was a feast for dynamics, a challenge that made graduate students smile the way climbers smile at an unclimbed face. If this was nature, it was nature at her most baroque. If this was artifice, it was art at its most modest. Then the universe blinked, and so did we. The blackout period was not cosmic, no eclipse, no transit behind a planet, just geometry turning the line of sight into the glare wall of the sun, the one region where even our best instruments are persuaded to humility. In that bright erasure, the Deep Space Network logged an unscheduled maintenance window. A solar observatory reported a calibration update with a redacted appendix, and a scheduled press briefing shifted to internal review without explanation. This is how suspicion grows, not from grand conspiracies, but from overlapping banalities, each one individually unremarkable and collectively suggestive. NASA is not a monolith. It is a cathedral of teams and contracts, of policies written by lawyers and dreams written by physicists. Yet in this pause, the public data cadence lost a beat, and independent observers felt the silence like a pressure change. When the object re-emerged from glare, its brightness had dipped more than slope models predicted, and a narrowband feature rumored in a private mailing list was absent in the official release. Was it weather? Was it pipeline? Was it the normal messiness of frontier science misread as secrecy? Suspicion does not need an answer. It needs only an echo. In parallel to skepticism, pragmatism did its work. What do we learn if we assume the least? What do we prepare if we assume the most? The least gives us new comet physics, the possibility of materials that assemble under interstellar tides with properties that challenge our laboratory analogs, a better handle on radiation pressure in aggregates. The most gives us probability's audacity, that someone somewhere long ago constructed an object that could endure the cold, cross the gulf, and whisper with sunlight. For future missions, both pathways converge on urgency. A rapid response architecture begins to look less like a hobby and more like a mandate. Microprobes waiting on the shelf, solar sailors pre-deployed in graveyard orbits, telescopes with modes that pivot from survey to interrogation in minutes. Policy shifts from track and catalog to intercept and character to rise. Budgets slide numbers from later columns into earlier ones, and a new acronym is born because new programs are born wrapped in names. Philosophically, the implications write themselves with trembling pens. If this is nature, then the universe is more inventive than our textbooks have admitted. If this is artifact, then the Fermi paradox acquires a footnote that points not to absence but to subtlety. Either way, we have been spoken to, even if the language is motion and the syntax is light. In the months that follow, a second wave of data arrives. Thermal constraints sharpened by JWST's patient stare at the object's outbound leg. Polarization curves that suggest surface microtextures inconsistent with typical comet fluff. Radar speckles teased from noise by algorithms that were still dissertation drafts the week before. The non-gravitational acceleration fades as the geometry cools, which is what both the outgassing and microthrust models predict, practical agnosticism disguised as convergence. A consortium publishes a sober paper arguing for a highly porous, low-density aggregate with intermittent sublimation from deep pockets of supervolatiles accessed by microfractures. Another paper, equally sober, shows that a meter-scale multi-layer structure with engineered laminates could produce the same dynamics under sunlight alone. No one says definitive. Everyone says interesting. NASA's internal review quietly concludes that certain calibration steps were not documented in the publicly mirrored pipeline, and the documentation is updated with the kind of bureaucratic contrition that irritates people who prefer stories to footnotes. The blackout period becomes a case study in communication etiquette rather than malfeasance. But legends are not constrained by errata. In forums and cafes and late-night labs, The visitor remains a mirror. What you see in it is what you dare to ask of the world. So let us be bold, but let us be careful in our boldness. Consider a civilization older than ours by 1,000,000 years, an absurdly modest gap on galactic timescales, sampling stellar neighborhoods with objects that are not ships but instruments, not emissaries but seeds of knowledge. A wafer could learn the structure of a magnetic field by surfing it. A layered sheet could sip radiation pressure to fine-tune a drift past worlds it has no intention to visit, only to measure. Across eons, a fraction of those sheets would thread the thin band of detectability where species like ours notice. They would look like rocks left slightly ajar. That we can write such a paragraph without needing to lean on fiction too hard is itself a marker of our century. But the alternative paragraph, the one that sings the craftsmanship of ice and dust, is no less beautiful. Pores scaled like snowflake cathedrals. Thermal gradients, coaxing jets that imitate intent, a spin state that knits randomness into semblance. Nature is a better engineer than we are, and the cosmos has more patience than our grant cycles. In either story we win, because the prize is not confirmation or denial, it is the repertoire of questions we now know how to play. What then is our answer? It is to build eyes that can see faster and minds that can change slower. It is to keep a fleet of small interceptors in orbit or in warehouses where bureaucracy can't slow the launch key, to teach our telescopes the reflex of a hawk as well as the patience of an owl, to invite amateurs in private observatories into a scaffolding where their contributions integrate in hours, not weeks. It is to treat transparency not as charity, but as instrument stability. Data release live with caveats as thorough as the plots. It is to rehearse the choreography of surprise, because whether the next visitor shouts with a tail like Borisov or whispers with a flatness like a sail, the window we get will be short, and the universe does not repeat a moment because we were busy. This is a species-level competency, rapid inference under uncertainty, humility stuck to courage like a fused alloy. The story of Three-Eye Atlas, whether ultimately shelved under complexly natural or suspiciously elegant, will be remembered as the drill we did or the test we failed. Let it be a drill. Let it be the day we started building the tools that will make the next day obvious. You can already feel the future leaning in. Mission concepts named for wind and myth sketch arcs that depart from Earth with the lazy energy of sunlight and arrive at intercepts with the precision of a heartbeat. A new generation of sky surveys stacks depth with cadence, catching fast transients without losing the slow ones. CubeSats grow cleverer. One holds a spectrometer that would have filled a room 20 years ago. Another unfolds a mirror so thin it feels like a rumor. The public learns new words, eccentricity, albedo, polarization, and claims them with the delight of ownership. Philosophy too gets busy. We debate the ethics of intercept, the etiquette of interpretation, the dangers of declaring will where none exists, and the equal dangers of denying will where some does. We remember that Copernicus did not displace us from the center of everything to make us small. He displaced us to make the universe large enough to breathe. The third interstellar messenger, whatever it was, has already changed us by asking us to be ready for the fourth. In the end, Three-Eye Atlas becomes what all great scientific objects become, a chapter title under which many authors write. Some will say it proved nothing extraordinary. Some will say it proved that ordinary nature is extraordinary. A few will keep a candle lit for the possibility that it was a tool from a mind we have not yet met. NASA's hidden truth under review resolves into what most truths are inside large institutions, a tangle of procedures, an honest bias toward caution, a reluctance to speak before the room agrees on grammar. That is not the conspiracy many wanted. It is the reality most of us work in. The sky forgives us our impatience by being endlessly generous with new puzzles. The archive keeps its dignity. The public keeps its appetite. And somewhere in the dark between stars, an object not unlike Three-Eye turns imperceptibly, waiting to cross a boundary that is invisible until you name it. When it does, we will be watching with better eyes and steadier hands, ready to feel that old electric vertigo, the sensation of standing on the edge of comprehension while something vast and precise approaches with the calm of truth,